Hello, hello, and welcome to this week's episode of Coffee with Thorben. I hope you grabbed your beverage of choice and had a great week so far. Special welcome to everyone who's already talking in the chat. Yeah, I did my best to already welcome everyone there. And Daruga, as I wrote, in case I don't talk about the different join options, please remind me. I will make sure that I'm pretty sure that I have an example about all these joins that I can share on today's stream. Okay, so what are the topics for today? The topics for today are association mapping pitfalls. Let's get into that right away. So association mappings with JPA and Hibernate seem to be totally easy. It's one of the most basic things to do, right? I mean, just put an annotation on a collection or an attribute of type of an entity class, and that's basically all you need to do, and you have an association mapping. Well, probably all of us know in reality it's a little bit tricky to do it the right way. The basic mapping gets you pretty far, but there are several things that could go wrong. And these are the things that I want to talk about today. But before we talk about that, I want to share something with you, and that is the page thorbenjansen.com/live, where you can find all the live streams that I did so far. And if you click on the banner of one of them, in this case the one from today, you see the live stream embedded here, the chat box, and that's probably the most interesting part, you see the different links and articles that I will reference during this talk down at the bottom, so you can find all of the resources there. And they stay there, they keep the video embedded. If you can't join live, just take a look at that article for the week, and then you're good to go and can take a look at the stream recording later on. Okay, let's jump into the IDE. So for today's talk, I will use some of the examples of my Cause of Death Hibernate talk, where I show several pitfalls with association mappings. Let's start with the first one, which is typical removal operation. So we have a book and an author entity. Let's take a look at the book entity first. So that is a pretty basic entity. It has a primary key, some attributes. Please ignore all the commented out code snippets here. We will use some of them during this live stream as well. So here we have a list of authors. It's of type list, and it's a many-to-many association, a pretty common mapping, and where based on typical Java knowledge, a list is a very efficient collection type, right? So using a list should be a great idea if you want to map a many-to-many association. Well, with Hibernate, unfortunately, it isn't. And this is something that I see quite often in my consulting projects. So what we have here is I get a book from the database, then I get all the authors and remove just one of them. In this example, the first one. So we would expect that, because this is a many-to-many association between the books and the authors, that we now see one SQL statement in our log file that removes that specific record from the association table, right? I mean, that would be what we would do if we write our SQL statements ourselves. Unfortunately, that's not the case if you're using a list for a many-to-many association with Hibernate. So what do we see here? So we see that we get the book entity. Sure, that's the one that we get by the entity manager find method. Then we access the association to the authors. So Hibernate has to fetch all the authors for the books. So far, so good. Well, Hibernate does some update on the book. Let's ignore that for now. What's critical here is this part. Here we have a delete statement that removes all records from the book author table, which maps the many-to-many association for that specific book. And after that, Hibernate inserts all these records. 1, 2, 3. So in the beginning, there were 4 authors who have worked together on that book. We removed one. Hibernate then generated an SQL delete statement here to remove all of these records from the database and insert the remaining 3. That's not that great. It requires way too many resources. It looks really strange in our in the auditing logs and everything, and it's something we should better avoid in general. So what can we do against that? There's a very simple fix for that, and that is that we just need to switch the data type for or the attribute type for the many association from list to set. And if I do that, then of course I need to go down here and also change my getter and setter methods. Okay. Just give me a second. Oh yeah. Okay. All right. Okay, let's see. Now it should work, hopefully. Yeah. Okay, now we replaced our list with a set. And as you can see here, we now have the update statement on the book that we had before, but more importantly, we just have one delete statement that removes that specific entry from the book author table. So we now only remove the record that we actually wanted to remove by removing this association here. Another thing that helps or that is better when using a set, let's quickly switch that back to a list, is that in some situations we might want to fetch 2 associations of an entity. So in this case, I want to get a book entity with an initialized list of authors and an initialized list of reviews. And well, if you do that and model your association types as a list, then you will get this exception here, a multiple bag fetch exception. A bag is a Hibernate-specific data type that is an unordered collection. So there are 2 ways to get rid of this exception. One is to just not do 2 left joins, to join fetches, which is often a good approach because when you're doing a join fetch, then you're creating a product. That's just how SQL works when you select all attributes mapped by the book entity and all attributes mapped by the author entity. And that book was written by 3 authors. Then you will get the book with author 1, the book with author 2, the book with author 3. So you will get the information of the book 3 times. And that can create a pretty huge result set, which causes performance issues. But let's say your associations are relatively small, so you don't have a lot of elements in that. Then it can be beneficial to use this approach and just accept a slightly bigger result set instead of executing multiple queries to get first the books and then to get the authors, or to get the books with the authors and then the reviews. So in this case, you always have to decide which trade-off you want to accept when optimizing this approach for performance. So it can make sense to join fetch multiple associations. And to be able to do that, you need to use a set. Otherwise, you're running into the multiple bag fetch exception that we just saw. So if I switch this back to a set and run the same test case again, you can now see that the test case was successful and that we have here our left outer join clauses. So this is a good time to answer the question that Daruga posted in the chat. And he wanted to learn more about inner joins, self joins, left joins, and outer joins. So what do we have here? We have a left outer join. So a left join and an outer join are in most cases the same. So an outer join can be a left outer join or a right outer join. With JPA, we in general use left outer joins. And that means that we, in this case, want to get all the information from the book, even if there is no entry in the book author table. In that case, everything that's not belonging to the book table would then be null in the result set. If we would use if we would use an inner join or just a simple join, which is exactly the same, then we would not get any books which have no records in the book author table. In this case, probably not an issue because, well, someone has to write the book, right? So there should always be an author for a book. But then we have the reviews down here. There it might be the case that we have a book for which we don't have a review yet. For example, because it was released today. Nobody had a chance to actually get one of them, get a copy of it. And a safe join would be a join between a book and a book. So you would join on the same table. I don't have an example for that here, but if you model an association here on the book table, that is an association to a book, then you could easily join that in your query as well. Okay, then let's talk about another pitfall. Let me see. Yeah, this is the next example that I want to show. Okay, so here I'm using Hibernate's query cache, and I'm caching this query here. So I want to select all the books with the authors and the reviews. I activate caching. I activated the caching on the book entity and on the author entity. And well, if we now execute this query here and join the two associations, and then down here, you can see we execute the exactly same query again, then you would probably expect that this query down here doesn't cause any database queries, right? I mean, everything here is cached. Well, let's see. So we can see now here that this is the second query, and there are lots of SQL statements. They are selecting information from the author table and information from the review table. Let's see, yeah. So the first one is for information of an author for a specific book, and the second one for the book. That's strange. Let's see. What did we do? We selected all the books with a left join fetch clause for both association. And it looks like that we only got the books from the database. So why is that the case? That's the case because we cached a query that returns entities, book entities in this case. And the query cache, Hibernate, only caches entity references. And that reference then needs to be reserved against the first or second level cache. So first of all, it's important that we annotate that we cache the book entity. And we did that by annotating it with cacheable here. What we missed is to tell Hibernate that we also want to cache the association between the authors and the books. And that's something that we discuss in great detail in my Hibernate performance tuning course. You can find the online course on my website. There it's currently a waiting list up. As soon as we have a small group of people who want to go through the course, then I will open that course to that group. So if you're interested in it, make sure to join the waiting list, and there will be a live workshop in spring of this year. I think it's in April. You can find that on thorbenjansen.com as well. So yeah, we added the cache annotation here, and I do the same for the reviews. And what Hibernate now does is Hibernate stores the book entity, the author entity, the review entity, and all the association between them in the cache. And due to that, we can now see here that we didn't execute any JDBC statements. We got all the information from the second level cache. Also, see up here, there started our second iteration, no SQL statements to be seen. Okay, third and final thing that I want to show here real quick is something about managing bidirectional associations. So we modeled the books association here on the author entity, and we modeled it here on the book entity. And the book entity owns the association, which means there is the many-to-many annotation that defines how this association gets mapped. On the author entity, we have a map by attribute on the many-to-many association that references the attribute on the book entity that defines the association. That's why this side is called the referencing side, and this side is called the owning side of the association. And well, if we now get an author and a book, and we say, okay, let's remove the book from the author. It's actually set there by accident. So let's see, then we should now, and we remove that here, then we should see in our log file that the entry from the association table gets removed, right? Well, unfortunately not. So if we look here, we have a select to get the author, we have a select to get the books. We have a select statement to get the association between the author and the books. And down here again, that would be a different topic. We could dive into more detail at a later point, or probably at a different stream, why we see all these statements. But what we can see here is that we don't have any remove operation on the database. So the association is still there. And we also see that here in the log output, where Max Mustermann still, where Max Mustermann on the entity has no association left to the book, but if we check the book, then it's still written by Max Mustermann. So let's see. The reason for that is that we just updated the referencing side of the entity, and that's something you should never do. You always need to update both ends of a bidirectional association. High need trust. So let's change the code and say, okay, we don't update the referencing side, we now just update the owning side. And this is better, but still wrong. And you will see in a second why. So we now see that we removed the record from the book author table. So in the database, book 1 and author 1 are no longer connected, which is good. It's way better than what we had before, but we still have inconsistent data in our current persistence context. The author entity of Max Mustermann still thinks that he wrote book 1, but book 1 is no longer associated to Max Mustermann. Yeah, Nitras, I'm reading the chat. I will talk about inserting by query at a different time. Today we're talking about managing associations and command pitfalls there. So then let's fix this code. So the thing that we need to do is we need to update both ends of the association. Let's do that here. So we now update the books association on the author entity and the authors association on the book entity. And if we now look at our log output, we can see that the book author table got updated and both entities are now up to date. So Max Mustermann no longer wrote book 1, and book 1 currently has no author. So please always make sure to update both ends of the association. Never update only one end. In worst case, you will not persist your change at all. And in the best case, or in the better case, you will update it in the database, but your entity, your entities in the persistence context are outdated. So there are two ways to solve that. And yes, Thomas in the chat is right. We could solve this problem also by enabling bytecode enhancement. And I should also have an example for that. So, but what I recommend in general is to provide a method called remove author. And remove author, in this case, is implemented on the book entity. And there we have the two operations that we need to perform. So on the book entity, we remove the association from the book entity, and then we remove the book object from the author entity that was provided. And then that works in the same way as the code that we saw before. So there's the remove operation, there's the update. Okay, yeah, let's take a look at the chat and see what we have here. So Telesuko asks, please make a real-time project using Hibernate with microservices. Yeah, I have an article about that on my blog. I can definitely share a link to that. Let me see. Where I discuss if you could or should use Hibernate with or for your microservices. And well, to make it short, the answer is yes. There's nothing that should keep you from using Hibernate to implement a microservice if the stuff that you implement for a microservice is a good fit for Hibernate or an object relational mapping framework in general, which might not necessarily be the case. Yeah, but I discussed that in more detail in the article that I now paste into the chat. Okay, I already answered Nitro's question. Thomas wrote, could you solve this problem also by enabling bytecode enhancement? Yes, you can. Let me switch to different IDE. Yeah, okay. So if you activate bytecodes enhancement by adding Hibernate's bytecode enhancement Maven plugin to your build process and set enable association management to true, then this example should show the association management. So what Hibernate then does is Hibernate adds code at build time to your getter and setter methods and makes sure that the association is managed. Now the question is, what's going on here? Oh no, the test was successful. Okay, so this was just Oh yeah, this was just a database update, and we are using a different database now, so that then looks a little bit confusing. So what we do here is we persist an author, we persist the book, and only on the book we set the association to the author. So here on the author we have, in this case, one-to-many association from the author to the book. And it's a bidirectional one. The book is the owning side of the association. And if we just set it here, then the author, the list on the author entity gets updated, and we can check where it contains that it's also containing that specific object. So yeah, Hibernate's bytecode enhancement feature with enable association management can make that a little bit easier and prevents you from updating both ends of the association programmatically. Okay, Ilya, I will get back to your question when we go to the Q&A part of the stream in a few minutes. But right now, we'll pick Ash's question because that one seems to be directly related to what I showed here. And he asked if there are any downsides to switching the owning and referencing parts of the association in book's author. In this case, no. Because it's a many-to-many association, and the association information are stored in an extra database table, in the book author association table. In this case, it doesn't matter on which end you model the owning or on which you model the referencing side. That would be different for a one-to-many association or a one-to-one association, where you have foreign key columns that are stored on one specific database table, and that then usually is the owning side of the association. For one-to-many, it is definitely the owning side of the association. For one-to-one association, you could create a mapping where the foreign key is stored is not stored on the table that gets mapped by the entity that contains the owning side of the association. But that's a really bad idea. So technically it works. Performance-wise, it's a rather complex and slow approach because Hibernate needs to execute additional queries all the time. And that means that you should better avoid that. Oh, sorry, I can't pronounce your first name, Bishop. Thank you very much for the kind words. Really happy to hear that, and great that that I was able to help you and your team. Okay, then let's get into this week's recap. You can find the links to this week's content in the chat in a few seconds. Yeah. Let me share that here. So there we have the article and the YouTube video. So in the article, I gave a quick introduction to implementing batch jobs with JPA and Hibernate. And in general, that's almost always not the best approach because object relational mapping frameworks like JPA and Hibernate create an overhead by providing their object relational mapping. And in most applications, we are more than happy to accept this overhead because we get a lot out of it. We get way better usability and developer productivity, and we can benefit from all the performance tuning features that are provided by these frameworks. Unfortunately, that's most often not the case for batch jobs. in batch jobs, we usually don't benefit that much from the delayed execution of an update or insert statement, or from the traversal of an entity graph or something like that. And because of that, other frameworks often perform a little bit better for batch jobs. If you want to implement batch jobs with Hibernate, and there could be good reasons for that, for example, because you want to reuse some of your code, then you should take a look at this article where I talk about how to optimize read operations, how you can optimize your write operations using JDBC batching, for example, and if and how you could manage your persistence context if it contains too many objects. Second topic of this week, or new content that I published, was on the YouTube channel, and that was about result set mappings. In this video, I show you how to map your the result of your native database query to a set of entities and scalar values, and that is definitely something that you should look into if you want to work with native queries. Okay, any questions about that? Oh, Gaurav, thanks for the kind words. I'm doing my best. And then I see a few more questions here in the chat that I will talk about in the Q&A section in a bit. Just give me a few, 2 or 3 more minutes, and then we go into the Q&A. Before that, I want to quickly talk about the question of the week. This is something where you can submit your questions in advance, for example, by posting them on Stack Overflow and pinging me on Twitter at thjansen123, or you could post your question on the blog. You will find a form for that later today on thorbenjansen.com/live. So this week, I had a look at this question on Stack Overflow. So here was someone who wanted to customize the mapping of enums in their entity mappings. And there is a relatively simple way to do that. You can provide your own attribute converter. This is something that was added in, I think it was JPA 2.1, and you just need to implement the attribute converter interface annotated with @converter, and then you can implement these 2 methods that convert your enum value to their database representation. And if you set the auto apply attribute to true, then you can use the enum attribute in your entities without any additional annotations. Hibernate will automatically pick the attribute converter. What's important then is that you don't annotate your entity attribute with @enumerated. The JPA specification doesn't allow that because, well, the enumerated annotation and the attribute converter both provide mapping information. They both define how the entity should be mapped to the database column. And well, that just doesn't make any sense. Which one should the persistence provider pick, right? That just doesn't work. So if you want to use your attribute converter to convert your enum values, then just don't add an enumerated annotation here. And well, if you provide your own mapping, then you can do something like what the thread opener here wanted to achieve. And he wanted to map values that are not supported by the enum to null. And you could do that by handling that case in the convert to entity attribute method, where you just say, well, okay, I know these values, I map them to an enum value, and in my default case, I return null. That works from a mapping point of view, but there's one thing you need to be careful about. If we get the vehicle I don't know, if we get the letter A back from the database, which doesn't match any of these strings here, then we would set that value to null. If you now change any other attribute on the trip entity, then Hibernate would perform a dirty check and replicate that change back to the database and automatically set the vehicle column to null. That's something you then need to keep in mind. Okay. That's about this. So let's take a look at the chat and answer all the questions that I see here. So yeah, let's start with Ilias' question, and that was, how can you do save or persist with Spring Data JPA? So I expect that you are using a repository, right? Probably a JPA repository. And in that case, you can simply inject the repository into your service and then call the save method on the repository with the entity. And you only need to do that for insert operations. Please don't do it for update operations. Your persistence provider, which is most likely Hibernate, will perform a dirty check on all managed entities, find all the entities that you changed, and then persist the change automatically. There's no need to call a save method for updated entities. What else do we have? I answered that question. And then Vishal asks, should I create a separate jar for DAO entity models for reusability, or should I use Spring Data REST, which is a better design strategy? Well, the usage of a separate jar for DAO or using Spring Data REST is, well, they're basically two different things. So the main question I think here is, should you use entities or no, should you use your own generated API layer and persistence layer, or should you use something that's generated? And I always recommend to implement your API layer and your and the code that accesses your database separately, because by separating all these things, you are able to design your API in the best way for the API layer. And that means for the feature that you want to provide to all the people using your API. And you not just expose all the structures and details used in your database. So what I always recommend is design a REST API, and in that API use DTO objects, so no entities, and well, document them and make sure that you keep them stable over time to keep a stable and good API. And then implement your business logic and your persistence layout. So as you're already mentioning Spring Data REST, I expect that you're using Spring Data JPA with their repositories. So there you have basically all the abstractions that you need between your business code and the database. The only thing that you now need to do is implement the business logic and make sure that in that business logic, you only work with entities when you are writing data. In all other cases, you should use DTOs, and make sure that you then transform your your objects to DTOs before you expose them on the API layer. And let me quickly check. If I can find, yeah, there it is. I wrote an article in which I discussed that in great detail. So in which I discussed using entities in the API and why I prefer to use DTOs. Let me quickly paste that into the chat. There it is. Okay. Okay, then there's a question from Van. Could you talk about recursive in JPA when it happens and how to avoid? Well, that can only happen if when can it happen? But it can happen whenever you designed basically a circle in your association mappings. So let's say we have an author and we have books, and we model it as a bidirectional association. So if I now get an author and then get the books for that author, and for each of these books I get the authors again, I could create a loop, right? So that is something that doesn't cause any issues with JPA and Hibernate. Why not? So even if we set the fetching behavior to eager fetching, then Hibernate would get the author entity and recognize, okay, I need to initialize the book entity. And then Hibernate fetches the book entities for that author. And on that book entity, Hibernate then again sees, okay, I need to initialize the list of authors and gets them from the database. But for each of the authors of the book that Hibernate just got from the database, it first checks the persistence context. And there it will find the author entity that we already got. So in that case, Hibernate will ignore the record from the result set and just pick the one that is already mapped to an entity object. And because of that, we don't need to worry about any recursion or anything there, because Hibernate will automatically break this recursion by reusing the entity that we already have in our persistence context. On that entity, we already have the book association initialized, so there's no need to do anything extra. What else do we have? Jenny asks, hey Thorben, how can we enforce lazy loading for many to one? I have a case where it does n+1 no matter what I do. The relationship is not used with JPA and native SQL. Where there's no way to actually enforce lazy loading with JPA. And that's because lazy loading is, in the JPA specification, lazy loading is defined as a hint. It's optional. Eager fetching has to be done by your persistence provider. If you tell your persistence provider to perform lazy loading, then this is something that is purely optional and depends on your mapping. So the question here is, how can you avoid the additional query, or how can you make it very, very, very likely that your persistence provider doesn't fetch the many-to-one association? And that would be probably by setting the fetch type to lazy on your many-to-one annotation. That usually works totally fine. Let me look at, no, that's the wrong IDE. Now we have it. Okay. So let's see. Association bidirectional many to one. Okay. So we have a book and review entity here, and we have tests. That's good. Okay, so what do we have here? We have our book entity. One book can have multiple reviews. So let's ignore that for now. So we have one-to-many association here. This is the referencing side, and it's of type list. This one is always, it's by default fetch type lazy. On the review entity, this is different, so we don't need this. So we have a many-to-one association here, and I set the fetch type to lazy on that book. And if I now fetch a review entity, then Hibernate shouldn't fetch the book entity for it. Let's see. Yeah, we probably create it separate. Okay, so if we now fetch the review, that's a review. And now I need a record from the review table. Okay. So using all the same sequence, 1, 2. So the first one should be review with the ID 3. Let's see. Okay, so Jenny posted that he had done that, but there are about 5 other many-to-one associations on the entity, but it fetches only one. That's interesting. Okay, so you can see here, there's no additional query. We only fetched the review, but you wrote about a native query. So let's get the review. Create native query. Select asterisk from review R. And we want a review class. R.id equals 3. Please never do this in a real application. It always should be a bind parameter. No inline parameters in real applications, please. Okay, broke something. What did I do wrong? Let's see. Inserting into the database quite a bunch of records. Okay. That's the case. It has to be 100. Yeah, I set the ID to 100. Let's see. And you can see again, there's no additional query. So I'm really wondering why that should be the case. Anything I don't have an object mapping between those two entities, only a foreign key. No. Any way to debug that? What the last question about that? Any way to debug that? Well, you could step into the post-processing of your query result, but that would probably be a pretty tedious thing to do. There's no great way to debug that. What you could do is you could post it on the question on Stack Overflow and send me a link to it. Then I will try my best to take a look at it next week. Or if that's an ongoing issue and you think you have a bigger problem with your persistence layer, then we can, of course, always talk about a consulting engagement for a short period of time where we work on that specific issue. But as you can see here with the standard mappings, that actually shouldn't happen. So we have the many to one here. We set the fetch type to lazy and it gets fetched. And the one to many here is lazy by default. Yeah. Oh, the only thing you could check is if the association is used in the equals or hashcode method. That sometimes happens by accident and it causes really strange error scenarios. And this one here could exactly match such a situation, where here, for example, in the hashcode, if you there include the association to the book, then Hibernate would need to fetch the book to actually calculate the hashcode. What else do we have? Deepak wrote, which layer is best to start transactions in an enterprise application? Well, that totally depends on your application and what you want to achieve by activating the transaction. In general, the transaction gets started on the API layer. So if you are implementing a REST endpoint, for example, then you would start the transaction on the method that maps the REST endpoint or on that class. Oh, Thomas made a great suggestion for one of the next streams, and he suggested to talk about JSON, the mapping of JSON columns. Yeah, we can talk about that. We can talk about that next week. That's a great idea. So next Friday, 3 p.m., which is the same time as today, on Friday the 22nd, we will talk about JSON mappings and how to use them with JPA and Hibernate. Thanks for the suggestion, Thomas. Great idea. Then there's another question. In a transactional method where only one table needs to be locked for a write, but others are being read, is there a way to keep the reading tables from locking? Yeah, my suggestion there would be to not use pessimistic locking at all, but to use optimistic locking instead, because it scales way better and prevents you from running into performance issues and deadlocks. So optimistic locking would require an additional database column where you keep a version number and you annotate the entity attribute with that version, and that is, well, optimistic locking is basically an automatic versioning approach and not a locking. And Hibernate then increments the version every time you change something on the entity. And then so this is what I wanted to show. Here you have the version attribute where you can then activate the optimistic locking. And I'm not sure if I have a pessimistic locking example here. No, unfortunately not, but you can can provide the log mode type as the third parameter to your find method. And by doing that, you can define the log mode. And you can set the log mode for the whole session. And you should be able to fine-tune that the logging approach there if it's supported by your database. But yeah, in general, my recommendation would be to avoid pessimistic logging in general. What else do we have here? So Ash has a situation where inside a transaction, they update about 2,000 records, then delete the record the updated records refer to, and on commit, there's still a foreign key violation. Yeah, that definitely can happen. So it depends a little bit on how the constraints are set up on the database level and when Hibernate performs all the write operations, which means SQL update and insert statements. So in general, a transaction only guarantees you that when you commit your transaction, it will be in a consistent state. And that means that before the transaction gets committed, there's actually no need to fulfill all the constraints. And depending on how your constraint is configured on the database, it might not even get checked. So based on that, it can happen that you perform lots and lots and lots of operations before the constraint gets checked and before the transaction gets committed, and you don't recognize that you have a constraint violation there. And then the next question was, why doesn't Hibernate do the update first and then the delete? Well, that's a good question. I have no answer for that. And as far as I know, there's no chance to tell Hibernate to do it in a different order. What you could do is you could perform all the update statements, then flush your persistence context. So call the flush method on the entity manager and then perform the remove operation. That would trigger Hibernate to first send all the updates to the database, and the delete statement then shouldn't break any constraints. Okay, what else do we have here? So Vishal tried to use DTO projections using the link provided in last stream. Yeah, last time we talked about that quite a bit, but I cannot convert type exception. I verified that the property names are same on both entity and DTO bean. I use the add value Lombok annotation to generate all args constructor and getter values. Okay, Vishal, I would need to see the code for that. All right, please either post a comment on that YouTube video or on the link that I provided. Was it for a YouTube video or for a blog post? And then please post a comment on that, and then I take a look at it and either answer there directly, or we do that on the next stream. See you next week, Thomas. Bye. Yeah, we are almost done here. We close this in a bit. So Raju asks, how can we generate dynamic queries based on search criteria like in an e-commerce application using Hibernate? What you can do there is you can use the criteria API. If you are, let's see, criteria. Unfortunately, I don't have an article for that. here right now. So Hibernate's criteria API enables you to do that. Let's quickly get into the IDE, and then we end the stream after that question. Criteria query. So what you can do, you can use your entity manager to get a criteria builder. That's a builder that you will use to create different parts of your query. And then you create the query. In this case, one that returns book entities, and define the from clause. You can do joins, inner joins, left joins, join fetches based on that root interface in the next steps. I don't need it in this case. I just use it down here to create my where clause with a like expression, reference the title attribute of the book entity using JPA's meta model, and compare it with this bind parameter, and then set the bind parameter down here. Yeah, so if you want to dive deeper into that, please take a look at either the Hibernate documentation or do a quick search on Google, or take a look at my Advanced Hibernate online course, where I have an extensive module about that, where we dive into all the details of the criteria API. But you see the quick rundown here, right? So you see the basic steps you need to do in the beginning. You need to create the criteria builder and then the query, define the from clause, create the where clause. And you can do all the things using the criteria API that you would normally do using JPQL. The only difference is here you're doing it via an API, and that gives you additional flexibility to create dynamic queries at runtime. Okay, and then last question from Deepak, and I will only answer that with the link. I'm sorry, but we are really running out of time. And Deepak asks, can we discuss on distributed transactions? Yeah, so distributed transactions, we have a link here. And okay, here we have the distributed transactions article there, for which I just posted the link into the chat. And then we can see here how a distributed transaction works. There we have a coordinator, which makes sure that all systems involved in the transaction first prepare the distributed transaction, which means they basically do a dry run and check if they could commit the transaction. And if they answer with compare, then the coordinator commits afterwards. That is in total a rather complex process, and it requires logs between the prepared and the commit. And that is why microservice-based systems and most other highly scalable modern architectures don't use distributed transactions. It's a rather complex approach that doesn't scale well, and because of that, we try to avoid that in general and use the Saga pattern, for example. You can learn more about that in the data and communication patterns for microservices course that you can see here, or you take a look at this article that I pasted into the chat, and the other 3 articles that I have on my site. They should provide you a good introduction to these topics. Talking about the courses, you can find all of them here on the site, or there on the online courses. And then Kieran asked, hi Tom, is this being recorded? Unfortunately at work now, but we'll love to watch it later. Yes, of course, it's recorded. Kieran, I see that you're on LinkedIn. So right now I'm streaming on LinkedIn, YouTube, Facebook, and Twitter Periscope. I'm not sure about the Periscope stream, but all other 3 platforms, YouTube, Facebook, and LinkedIn, keep the video, keep a recording of the live stream available. So you should be able to watch it later. And you can always go to torbenjansen.com/live, and there you find a list of all the live streams. So I just added the one from last week and this week, and didn't include the ones from the last year because we now have a new structure. But from now on, you will find all the articles here. Yeah. Okay, that's it for today. Thanks everyone for all the questions. Yeah, it was a pleasure. I had a lot of fun. I hope you enjoyed it as well. If you enjoyed the stream, make sure to follow me on YouTube for more videos, and maybe take a look at my website, thorbenjansen.com, where you can also sign up for my email list, where you get a reminder of all the new things that I'm publishing. In general, that is a blog article on Tuesday, a video on Thursday, and a live stream on Friday, and lots of other hopefully helpful material. Okay, enjoy your weekend. Have a great rest of the day, and I hope I see you again next Friday. Take care.